Okay, Susan asked me to do problem number 27. This asks you for the interval of convergence, for what value of x does the series converge absolutely, and what value does the series converge conditionally. Okay, so here's our series. I wrote out a few terms. So I went ahead and ran the ratio test, and when I run the ratio test, I see that I have a term with x. I move it on the outside. The limit is 1 as long as this is guaranteed. So this becomes my interval of convergence, which I think Susan was okay with. Now we need to test the endpoints. So the first thing I'm going to do is I'm going to test -1. So when I plug in -1, I get -1 to the n. And essentially it's times 1. So I have 1 minus 1 plus 1. So my use of n is actually this part right here, because this is the term forcing it to alternate. So when I go through my Leibniz, 1, 2, 3, use of n is positive, so that checks. Now, use of n plus 1, oh, it does pass this one. Less than or equal to use of n, that's true, but it fails the third one. The limit of use of n as n goes to infinity is not 0, it's 1. So we fail Leibniz. So -1 is not included in the does not converge at -1. Continuing on, now we're going to test when x equals 1. So putting 1 into our series, all I have to do is write out a few terms, and I can see that this diverges. So 1 is also not included at the endpoint. So my interval of convergence goes from -1 to 1. Remember that we converge absolutely on our interval of convergence. There's no mismatching. So it's the same as our interval, and there's nowhere where we are conditionally convergent. And that's it.